Hello my dear students, once again welcome back to our online education platform for the integrated classes, the VAVA classes. So this part I am solve question number 7. If A, B, C are non-coplanar vector, then test for the collinearity of the following points whose position vector are given: A minus 2B plus 3C, 2A plus 3B minus 4C, minus 7B plus 10C. Solution: let A, B, C be the given points respectively, then OA equal to A minus 2B plus 3C, OB equal to 2A plus 3B minus 4C, OC equal to minus 7B plus 10C. Now AB equal to OB minus OA, so A plus 5B minus 7C, SC equal to OC minus OA, so by subtraction it is minus A minus 5B plus 7C. SC clearly SC equal to minus AB, you can see SC equal to minus AB. So if A equal to lambda B, then AB are collinear. So SC and AB are collinear, that implies ABC are collinear. Okay, so prove this. 3A minus 4B plus 3C minus 4A plus 5B minus 6C, 4A minus 7B plus 6C. Solution: let ABC be the given point respectively, then OA equal to 3A minus 4B plus 3C, OB equal to minus 4A plus 5 minus 6C, OC equal to 4A minus 7B plus 6C, AB equal to OB minus OA minus 7A plus 9B minus 9C, SC equal to OC minus OA, this is A minus 3B plus 3C. There exists no scalar M such that SC equal to MAB. Okay, we cannot express SC as some constant multiplication of AB. Okay, you can see from here. So ABC are not collinear. Now question number 8. If A equal to 2I plus 5J plus K, B equal to 4I plus MJ plus NK, and AB are collinear, find MN. Solution: A, B are collinear, that implies B equal to TA for some scalar T. That implies 4I plus MJ plus NK equal to T time 2I plus 5J plus K. Equating the corresponding components, 4 equal to 2T, M equal to 5T, N equal to T. So T equal to 2, M equal to 10, N equal to 2. Okay, so these are the value. The question number 9. If the vectors minus 3I plus 4J plus lambda K, mu I cap plus 8J cap plus 6K cap are collinear vectors, then find lambda and mu. Given minus 3I, if AB are collinear, then A equal to MB, where M is a scalar. Given minus 3I plus 4J plus lambda K, mu I plus 8J plus 6K are collinear vectors, that implies mu I plus 8J plus 6K equal to M into minus 3I plus 4J plus lambda K for some scalar M. That implies mu equal to minus 3M, 8 equal to 4M, 6 equal to M lambda. So M equal to, by simplification, M is 2, so mu is minus 6, lambda equal to 3. Okay. Now question number 10. A, B, C are non-collinear vectors if alpha equal to x plus 4y A cap plus 2x plus y plus 1 B cap, beta equal to y minus 2x plus 2 A cap plus 2x minus 3y minus 1 B cap, then find xy such that 3 alpha equal to 2 beta. Now solution: given 3 alpha equal to 2 beta, that implies 3 times x plus 4y A cap plus 2x plus y plus 1 B cap equal to 2 times y minus 2x plus 2 A cap plus 2x minus 3y minus 1 B cap. So 3 into x plus 4y minus 2 into y minus 2x plus 2 A cap plus 3 into 2x plus y plus 1 minus 2 into 2x minus 3x minus 1 B cap equal to 0 cap. So 7x plus 10y minus 4 A cap plus 2x plus 9y plus 5 B cap equal to 0 cap. So 7x plus 10y minus 4 equal to 0, equation 1. 2x plus 9y plus 5 equal to 0, equation 2. Now solving 1 and 2, we get 9 1 minus 10 in 9 into 1 minus 10 into 2. By solving this, we get 43x minus 86 equal to 0. So x equal to 2. Okay, substitute x equal to 2 in equation 2. 4 plus 9y plus 5 equal to 0. 9y plus 9 equal to 0. So 9y equal to minus 9, y equal to minus 1. So x equal to 2, y equal to minus 1. Okay. Now question number 11. If ABC are non-coplanar vectors, then show that the 4 point 6a plus 2b minus c, 2a minus b plus 3c, minus a plus 2b minus 4c, minus 12a minus b minus 3c are coplanar. Solution. Let A, B, C, D be the given points respectively. OA equal to 6a plus 2b minus c, OB equal to 2a minus b plus 3c, OC equal to minus a plus 2b minus 4c, OD equal to minus 12a minus b minus 3c. AB equal to OB minus OA, so minus 4a minus 3b plus 4c. Similarly, SC equal to OC minus OA, so minus 7a minus 3c. AD equal to OD minus OA, so minus 8a minus 3b minus 2c. Now, the determinant of coefficient of SB, SC, AD are minus 3, minus 4, minus 3, 4, minus 7, 0, minus 3, minus 18, minus 3, minus 2 determinant. This is equal to minus 4 into 0 minus 9 plus 3 whole into 14 minus 54 plus 4 whole into 21 minus 0. By simplification, it is 36 minus 120 plus 84 equal to 0. So FB, SC, AD are coplanar. Since the determinant is 0, determinant of coefficient of FB, SC, AD are 0, so it is a coplanar vector. So FB, SC, AD are coplanar vector. That implies FB, CD are coplanar. Okay. Now question number 11. Let ABC are non-coplanar vectors. Then prove that the 4 points minus a plus 4b minus 3c, 3a plus 2b minus 5c, minus 3a plus 8b minus 5c, minus 3a plus 2b plus c are coplanar. Now solution. Let OA equal to minus a plus 4b minus 3c, OB equal to 3a plus 2b minus 5c, OC equal to minus 3a plus 8b minus 5c, OD equal to minus 3a plus 2b plus c. Then AB equal to OB minus OA, 4a minus 2b minus 2c. SC equal to OC minus OA, minus 2a plus 4b minus 2c. AD equal to OD minus OA, minus 2a minus 2b plus 4c. Now 4 minus 2 minus 2, minus 2, 4 minus 2, minus 2 minus 2, 4 determinant equal to 4 into 16 minus 4 plus 2 into minus 8 minus 4 minus 2 into 4 plus 8. So 48 minus 24 minus 24 equal to 0. The vector FB, SC, AD are coplanar. That implies ABCD are coplanar. Okay, the determinant is 0, so ABC, SC, AD are coplanar. That implies ABCD are coplanar. So this is all about this part of addition of vector. So next part will solve more problem based on this. Okay, so thank you once again, students.